Which real numbers are equal to their cubes?
Which real numbers are equal to their cubes? Just one, right?
And -1.
True.
That's all I
Is
can
that
think
it?
of, right? Anything else is going to be much bigger or much smaller.
Right. So I guess you just need to think about how properties of numbers and how they behave. So they said which real numbers are equal to their cubes. So real numbers are, well, actually it's everything but imaginary. It's all the numbers you've been working with except for imaginary numbers. So if you know the properties of numbers and how they behave, really what we're kind of asking is x cubed is equal to x. Like if we had something like that, we're wondering, I don't know, could we solve this algebraically this way?
I'm not sure how you would solve that algebraically that way. I don't know if I feel like the most efficient way is to just try numbers, but then you might be missing some rational numbers, right? That you aren't sure about. Oh, you could. Yeah, because you just, so set it equal to 0.
You know, so minus, and then factor out an x, so x squared minus 1. Yeah.
And
so
that
0.
gives us the numbers that we,
okay,
yeah.
All right, let's do that. So also, all right. I have not seen this question before, so I just kind of had to think about that first. I'm sorry, I apologize. You saw my process there.
Yeah, these problems can be tough because they're related a lot to number theory, and you have to think about an equation like x cubed has to equal x,
right,
and then go from there. Yeah.
So I was just kind of thinking of numbers and knowing how they behave. I was thinking, oh, well, I know that 1 cubed, you know, if you take 1 times 1 times 1, that's still going to equal 1. And that's really what they're asking is what number cubed is going to equal itself. And then we also mentioned -1 cubed is going to be itself, and then also 0 cubed. So if we solve it algebraically, you know, we can actually create an equation for this whole thing. And I'm kind of proving the answers here. 0 cubed would also be 0.
And actually, I think this algebraic way is great because we did not say 0.
We didn't say 0.
We forgot it.
But
it's very easy
the algebraic method will show you that 0 is an answer. So setting up an equation, this equation makes sense because we're wondering what number, that's going to be our x, cubed is going to be equal to that same number. So this equation, we can set that up, and if we can solve for x in this equation algebraically, then we know which numbers cubed equal themselves. So what I started doing is I subtracted x from both sides because I'm setting this equal to 0. A lot of times when you're solving equations with higher powers, second power, third power, fourth power, this is a really good strategy to use if you are solving these types of equations. So then on the left side, I have x cubed minus x, which, you know, they're not like terms, so they don't combine. And then from here, again, a strategy to solve higher degree functions or equations is to factor, get them into factored form. So this is why I factored out an x from both of my terms. So I take I took x cubed divided by x, and I get x squared. And I took -x divided by x, and I get -1. It's kind of like backwards distribution. And then this right here, if we were to factor that, that's called difference of squares. And the way that those factor is like, I'll give you an example here. If I had x squared minus 25, that would factor to x plus 5, x minus 5. You take the square root of the first term and then the square root of the second term and do a plus and a minus in between. So if I were to do that here, it'd be factoring to x plus 1, x minus 1 equals 0. And the reason why this is a algebraic strategy to solve this is what you can do is use the zero product property to solve, which means anything times 0 is just 0. And what we're saying here, let me get this, is I have something times something else times something else. And that's all equal to 0. So if any one of those 3 factors were equal to 0, this equation would be true. So I set up that. I say this factor is equal to 0. I say my x plus 1 is equal to 0. And I say my x minus 1 is equal to 0. Now I want to find out what x would actually be. The first one's already done for us. X is isolated. It's 0. And we actually saw that one up there. Here I have one step, which is just to subtract 1 from both sides. So x is negative 1. This is one that we found there. And then here I'm going to add 1 to both sides. And x is 1 here. And those were all answers that we got when we just kind of thought about, the concept of any number cubed equals itself, what numbers would behave that way. But this algebraic method is a really good way to make sure that you got them all, because we didn't say 0 at first. Yeah,
right.
That didn't occur to us. So I guess 2 ways to think about it, and a lot of times we are giving you a lot of different methods. One algebraic, one is more of a guess and check, but both work. So hopefully that helps. Sorry, you saw my thought process there at the beginning.
Oh yeah.
Because I didn't know that question was coming. I was like,
But yeah, it's a great exercise, right? Like kind of thinking these things out loud.
Yes.
And we wrote an equation, had to think about how to solve it. So that's what you should be doing.
Yes.
Yeah.
Makes it pretty transparent.